In our last lesson, 5-6, we're going to talk about z-scores, and z-scores specifically say how many standard deviations someone scored above or below. So we're not talking nice, neat, 1 standard deviation, 2, 3 anymore. Now we're starting to get into the nitty gritty. You get a specific score, your answer might be, well, you were above the curve, so you are at 1 standard deviation, but maybe you live between 1 and 2 standard deviations. We're going to find specifically, so you can get decimal answers here. All right. The z-score shows a value that is how many standard deviations from the mean. If your z-score is positive, that means you did better than average. If your score is negative, then you did below average. And then when your z-score is 0, that means you are exactly equal to, you are right in the middle. Here's our formula for z-score. To do the z-score, we need 3 different values. We need a data value, that's the score that we're measuring. The mean, you need to know the average, and you need to know what the standard deviation is. So it says z-score is equal to your data minus the mean divided by standard deviation. So a radar detector records speeds of a group of cars. If the mean is 46, and the standard deviation is 2.8, find the z-scores for each of these values. Okay. Zoom, zoom, double zoom. Okay, so here, my z-score is equal to my data value, which in this problem is 52, minus the mean, 46, divided by my standard deviation, 2.8. So that's going to give me 6 over 2.8. Calculator, come on, man. .14. So that was over 2 standard deviations above. That was really high up there given the data set. Okay, 42, all right. Well, my data value here is 42. I'm still gonna subtract the average and divide by 2.8. It's gonna be -4 over 2.8. This z-score is -1.43. So we're under the standard deviation, so we did below average by 1 standard deviation and then a little bit more. So it's really close to 1.5 standard deviations down, but specifically -1.43. And then lastly here, your data value minus the mean over 2.8. That's gonna be 1 divided by 2.8. 0.36. So not a full standard deviation, barely even above average, but just slightly above. Okay, and we knew that because if the average was 46, only 1 mile an hour more is just slightly above that average. Okay. The mean number of total miles ran last week by each member on the track team was 4, with a standard deviation of 1.2. If Clay had a z-score of 2.5, how many miles did he run? So break down what the problem gives you. It's going to give you at least 3 pieces of information of this puzzle. Remember, the z-score is equal to your value minus the mean over the standard deviation. The mean was 4. The standard deviation was 1.2. And his z-score, 2.5. How many miles? So we are searching for his data value here. We're searching for the x here. How many miles did Clay run? So let's take this formula and let's substitute in the values that we have. 2.5 equals his value minus the mean over the standard deviation, 1.2. Now this becomes a problem of algebra. How do I get x all alone? Well, currently x is being divided by 1.2. I'm going to multiply both sides by 1.2. But do that, 1.2 times 2.5 Convenient. That's 3. Now I've cleared this denominator because that cancels, x minus 4. All I have to do is add 4 to both sides. So Clay ran 7 miles. Let's take a peek at if this makes sense. The average was 4. We think we got 7. So he should be above average. The standard deviation was 1.2. Okay. So if he was, let's see, if he ran 1 standard deviation above, 4 plus 1.2, that would be 5.2. But he scored more than 1 standard deviation away. He scored at over 2, so at least 2. Let's add another standard deviation to that. 6.4. Okay. And he still scored higher than that. Well, if the standard deviation is 1.2, half of 1.2 is 0.6. Okay. So yeah, that does make sense. We could do that algebraically the long way, but it's not all nice and neat. The point is, if we scored well above the mean with a 2.5, that means he did very much better than average, then yeah, we should see a score pretty substantially higher than 4. Marker. Okay, a set of test papers is normally distributed, again, good, we need that normal distribution, with a standard deviation of 5. So z-score is equal to data value minus the mean over standard deviation. The standard deviation is 5. If they scored, this is their data value, an 83, and they had a z-score of negative 0.4, what was the average of the test? So we know that they scored an 83 and their z-score is negative. That means they're below average, just by a little bit, by half a standard deviation or so. So we should see a score higher than this for the mean. All right, let's go in and plug in the values we have into our equation. I know their data value was 83 minus the mean, I don't know what that is, and the standard deviation was 5. Okay, so just like last time, I need to clear this denominator. I gotta get m all alone. I'm gonna multiply both sides by 5. Now with a little algebraic maneuvering, I want to move the m over here so it's positive. I'm going to add m to both sides. And if I'm going to add m over here, I got to take this away. I'm going to add that. Actually, no, let's not skip that step. I'm going to add m to both sides. That's what it looks like if I just shift that m. Now I'm going to get this 2, and I'm going to get that 2 over there by adding it. The mean was 85. Now that checks. They scored slightly below the average, just slightly, and that makes sense because we're just a little bit below the standard deviation, or sorry, the mean there on that. And then lastly, the heights of a group of 3 trees, normally distributed, average 14.3, z-score was 20. For that, what is the standard deviation? Okay, no. Z-score equals data value minus the mean over standard deviation. Okay. So let's list the values we have. The mean is 14.3. The data value is 20 because we're talking about the 20-foot tall tree. It has a z-score of 1.9. What's the standard deviation? Okay, let's make sense of this. The z-score is 2.9. It's almost 2 full standard deviations above the average. So I'm expecting that the score is largely, yeah, above the average, and that makes sense. Okay, plug in our values. 1.9 equals 20 minus 14.3 over the standard deviation. And that's what I'm trying to solve for. Okay. The steps don't change, all right? I want to get that standard deviation out of the denominator. So I will simply multiply both sides by it. Over here now, this turns into 1.9 times whatever the standard deviation is. Treat it like a variable, treat it like x. And now it clears the top and the bottom here. Actually, 20 minus 14.3 is something I could have calculated. 1.9 times the standard deviation equals 5.7. And now we can just divide. Divide this side by 1.9. What you do to one side, you do to the other. So this is, the standard deviation is a nice, neat 3. Okay, let's see if we can figure this out meaning-wise. So, looks like if I add 3 to this, 14.3 plus 3, that would give me 1 standard deviation. And now I'm going to add a second standard deviation. And this number is too high. Our score was 20. So we need to be a little bit less than 2 full standard deviations. And that's where it comes from here, 1.9. It's a little bit less than that. Okay. And with that, we're not going to do the next page. Your unit is over. I wish you luck on the test or the paper, whichever you choose to do. Good luck.